Hello, welcome to our channel. In this session, we shall see structures in C++. We know there are different data types in C++ language. Data types are a way to handle different types of data. We have integer data type, we have floating point data type, we have character, double, void, etc. All these data types are called basic data types, primitive data types, or fundamental data types. So, int, float, char, double, void. These data types in C++ are called primitive, basic, or fundamental data types. Basic data types or fundamental data types. Fundamental data types. Why they are so called? Because these data types are already available along with C++ package. So these data types are not enough for handling different types of data. Using this, we can only handle integer numbers, floating point numbers, double precision floating point numbers, character type data, void, it indicates nothing, these kind of data. If the data becomes complex, we have to make use of structures. So structure is a user-defined data type. A structure is a user-defined data type. A structure is a user-defined data type. What does it mean? What is meant by user-defined? A structure is a user-defined data type, which means this data type is created by the programmer as per his requirement in the program. A programmer is going to write a program or develop a program. He wants a new data type as per his requirement. So based on his requirement, he creates or he defines a new data type. So this data type, structure, is a user-defined data type. This data type is created or defined by the programmer as per his requirement. Now, what is the other feature of the structure? For what purpose we are using this structure? A structure is used for combining different logically related data items. So this is the second point about structure. A structure is used for combining different logically related data items. For example, we want to store the details of a student. Say a student has roll number, a student has admission number, a student has his class, name, date of birth, then course of study, etc. We can take an example. We want to store the details of students. What are the different data to be stored about the student? What are the different data to be handled about the student? Say, roll number, name of student, date of birth, mark in different subjects, gender of the student or sex of student. So these are different data items or different entities about the student. So this roll number, most of the time it will be a number starting from 1 to 50 or 60. So that is an integer. Name, it's a collection of characters. So we can, it's a character or it's a character array can be used for that. Now, date of birth is another data type. It has DD, YYY format. Then marks in different subjects. Suppose a student is studying 6 different subjects. The 6 different marks of the subjects, the different subjects can be stored in an array. We have to make use of an array of integers. Then gender or sex, it can be M or F, M for male, F for female. So it can be a character. So for storing the different details of the student, we need different data types. So all these data types can be put together and the programmer can name all these different data types. So structure is a way to combine the different types of data together under a single name. By defining a structure, a user creates a new data type. By defining a structure, a user creates a new data type. Then after creating or after defining that data type, he can make variables of, or he or she can make variables of that data type. Let us see. Now, how will you define a new structure? What is the syntax to be followed in order to create or in order to define a structure? So the syntax is, we make use of the keyword struct to create a new structure. The keyword used is struct. Since it is a keyword, we have to make use small letters, struct. Now the next part is the proposed name for the structure. We have to give a name for the structure. If you are storing the details of a student, we want to store the details of a student, we can name it as student. If you want to store the details of an employee, we can name it as employee. If you are dealing with a shape, suppose we are handling a box, we are storing its length and breadth, we can name it as box. So there will be a name for the structure. It is called the structure tag. The name of the structure is called structure tag. Then we will open a curly brace. Then at the end it will close. Then there is a semicolon. In between these two curly braces, we will give number of variables that are used for storing different individual data. Say data type, variable 1, data type, variable 2, and so on, any number of variables. Data type, variable n, etc. So the keyword is struct, the name of the structure which is known as structure tag, then data type, variable name, another data type, variable name. So the necessary required number of data types and their variables are defined, specified inside this structure, and a curly brace, finally a semicolon. This will create, or this will define a new structure. Its name will be this. The name of the structure is referred by this structure tag. Now let us see an example. Suppose we want to store the details of a student. We are going to create a structure named student. We want to store the details of student. We want to store roll number, name of student, then sex of student. These are put together, and these entities, these items are together named as student. Now our aim is to create a new structure named student. It contains different data items, roll number, name, and sex. How will we define a structure named student? The way is, we are using the keyword struct. So here we want the structure tag. In this case, the structure tag is student. Now what are the contents inside this? Roll number, name, and sex. So here, data type, we want to store roll number of the student. Instead of roll number, we are using the word roll. For storing roll number, it will be numbers like 1, 2, 3, etc. So for handling that number, we are using integer and putting a semicolon. Similarly, we want to store the name. For handling the name, we make use of characters, and the identifier is name, variable is name, a maximum of 20 characters in the name. It's an array of characters. Then sex, again it is a character. It is sex, single character is enough. So this created a structure. The name of the structure is student. This is a structure tag. By doing this, we have created a new data type, a new structure named student. Now we can create the variables of this data type. What are the contents of this structure? It has an integer part, it has a character array, it has another character. The name of this integer part is roll, the name of this character array is name, the name of this character part is sex. Now, another example. Suppose we want to store details of an employee. An employee working in a firm or a company. Suppose we want to store employee ID, employee identification number, employee's name of employee, salary of employee, salary of employee, then department. Then these are the four things that we want to store about an employee. And all these data together we are naming as EMP for the time being. All these together we are naming as EMP. Employee ID, let it be a number like 40201234, something like that. Any number, an integer number. Name can be Raju, Ali, Alex, etc. Salary could be 45,000, etc. Department, sales, purchase, etc. Now we are going to create a new structure named EMP. So here we are using the keyword struct. Instead of the student, we are using EMP. So the structure that we are going to create newly is EMP. Now what are the contents? What are the elements of the structure? Employee ID. So it's a number, we are using this integer EMP ID, an integer number. Then name, its character, as the previous case, name. Then we are using 25 characters, so it is like this. Then comes salary, let it be float. Salary. Then department, again it's a character, right? DEPT of say some 20. For storing sales, purchase, etc. Name Raju, Ali, Alexander, etc. Employee. So this creates a new structure named EMP. So a structure is a user defined data type. It combines different logically related data items, and all these logically related data items are together identified by a name. And we use the keyword struct to create a structure. Then after this keyword, we will specify the name for the structure. It is often called as structure tag. Then after that, we will open a curly brace. Then each and every items in the structure are specified with its data type and its identifier or variable name. Then finally, the curly brace is closed and a semicolon is there. This defines a structure. Now, after defining the structure, we want to create variables of the structure for using a structure in a program. By defining a structure, it does not use any memory location. It does not allocate memory location. It is only a blueprint of the variable that we are going to create. Now, we will see how a variable of a structure is created. Again, we are taking the example student, struct student. It has say integer type, admission number, character, name of say 20, then say total mark, then his gender, then his group of study. Consider this example. Name of the structure is student. It has 1, 2, 3, 4, 5 different elements inside that structure. The first one is an integer, its name is admission number. Character, its variable name is name. Integer type, total mark. Character, gender, character, group. It's an array of characters. Now, we know how an integer variable is created. An integer variable can be created like this: int x. A floating point variable can be created like this: float y. A double type variable can be created as double db. A character variable can be created char ch. An array can be created like this: int array of 10. When we declare a variable like this, what happens? It allocates some memory in RAM, say 4 bytes in the case of GCC compiler. For Y also it allocates 4 bytes. For double it allocates 8 bytes in memory. For character it allocates 1 byte. For this array, integer array, for 10 different items, a total of 40 bytes will be allocated. That we know. Similarly, we have created a new data type. Here the data type is integer, here it is float, here it is double, here it is character, here it is integer. We have created a new structure. We have created a new data type. The name of the data type is student. Now we want to create a variable of this type, student type. How will we create? See, we are creating an integer variable like this: int x. Similarly, we are creating a variable of the student type. So we write student, say s, or student, stud, something like this. Now the question is, when we create a variable like this, so s is a variable of student data type. Here x is a variable of integer, it reserved 4 bytes. Here db is a variable of type double, it allocated 8 bytes. Here arr is an array of integer of size 10, a total of 40 bytes are reserved. Here ch is of type char, it allocated 1 byte. Now the question is, how many bytes will be reserved for this s? The answer is simple. We will take the bytes required for these each data items. So here s will be reserving here integer. If you are creating a variable of student type, say yes, how many bytes are reserved for s? How many bytes are required for s? The answer is here admission number is of type integer, it uses 4 bytes. If it is turbo C, it will be 2 bytes. For the time being, we are taking it 4 bytes. Then name 20 characters. 1 byte for 1 character, a total of 20 characters. Then total mark is of integer 4 bytes. Gender is of character type 1 byte. Character group of 20 bytes, a total of 20 bytes. So total 20 plus 20, 40, 40 plus 8, 48 plus 1, 49 bytes. How many bytes are reserved for this S? The answer is 49. How do we calculate? We are taking the memory requirement for individual data items. Admission number requires 4 bytes, name requires 20 bytes, total mark requires 4 bytes, here gender requires 1 byte, GRP requires 20 bytes, a total of 49 bytes. So in memory, for S, it will reserve for S this entire area. In memory, this entire area is named as S. Here, this 4 byte is named as X. Here, 4 byte is named as Y. Why? Because here we are declaring an X. Here we are declaring a Y. Similarly, here we are creating a new variable of type student. So, how many bytes? A total of 49 bytes will be reserved for S. Now we can draw the block diagram. The entire space is known as S. Of these, 4 bytes are for ADM number, 4 bytes. And of these, 20 bytes are for 20 bytes for name. And 4 bytes for total mark. Then 1 byte for, this is 4 bytes. Then 1 byte for gender. And 20 bytes for group. So a total of 49 bytes. In this way, the memory is allocated for this variable. Sometimes we can draw this like this. This is the total memory required for S. 4 bytes for admission number. Then 20 bytes for name. Then comes 4 bytes for total mark, then 1 byte for this gender, and again 20 bytes for this group. So a total of 49 bytes. This is the way of reserving or allocating memory for a variable. A variable can be declared using the structure tag. Variable of a structure is created using structure tag. Here the structure tag is student. Structure tag is the structure name. Structure name followed by a variable name creates a structure variable. The memory allocation takes place when a variable of the structure is created. By defining a structure only, it does not reserve memory for the structure. It is only a blueprint for the variable, how the variable is to be created. Then, when creating a variable, it will reserve the required memory. The total memory required for the structure can be calculated by adding the memory required for individual data items or different data items in the structure. So, we are concluding. A structure is a user-defined data type. It is used for combining different data items which are logically related, putting them together under a single name, and it is created or it is defined. A structure is defined using the keyword struct. Struct is followed by its structure tag. Structure tag is also known as structure name. So the structure definition. We can define a structure using the keyword struct. Then we can specify different data items in the structure one by one using the available data types. And we can create the variable of a structure using structure tag. Structure tag is used to create the structure variable. And we have seen how the memory required can be calculated. So that is for all for this session. Thank you.